Hi, and welcome to National Manufacturing Day. My name is Alex Warner. I am on the Economic Development team for the Forsyth County Chamber of Commerce. We have been able to put together a virtual tour of some of our manufacturers right here in Forsyth County. We could not have done it without the support of our sponsors. I would like to thank Automation Direct and Smith & Howard for their generosity.
Hello, I'm Shane Kreider, and everyone here at Automation Direct welcomes you to Virtual National Manufacturing Day.
Hi ladies and gentlemen, I am Marvin Willis, a partner at Smith & Howard. Smith & Howard is an accounting and advisory firm located in Atlanta, Georgia, and we are very active in Forsyth County. In fact, I'm personally involved with the Forsyth Chamber and really value the work the Chamber does throughout the community. Did you know Forsyth County's manufacturing industry employs over 5,000 individuals? National Manufacturing Day is today, October the 2nd. And here at Smith & Howard, we work with some of the most recognized manufacturers in the nation. Given our commitment to the manufacturing industry, I wanted to share a few stats with you about this great industry. Number one, manufacturers in Georgia represent 11% of the total output of the state. Number two, the manufacturing industry employs 9% of Georgia's workforce. And number three, the average annual compensation for Georgia's manufacturing employee was $71,000 in 2018. Given these impressive numbers, those of you on the call who are in high school may consider a career in manufacturing, whether as an executive, a cybersecurity officer, a line worker, or one of the other many available opportunities. Those are just a few of the positive statistics I wanted to share with you today. In closing, I want you all to know how important the manufacturing industry is and what a large and positive impact the industry has on Georgia and especially Forsyth County. Thank you for watching, and I hope you all have a great day and the rest of the school year. Take care.
Thank you again to our sponsors. Today we're going to go on 5 virtual tours of manufacturers right here in Forsyth County. First we're going to go to Solvay Specialty Polymers. Then we're going to go to behind the scenes at Automation Direct, Swagelok, Collins Company, and Siemens. Enjoy the tours.
Hello, and welcome to Solvay. I'm Donna Drake. I'm the head of the core laboratories here in the U.S., as well as the Alpharetta site manager. Since 1990, Solvay has been one of the largest employers in Forsyth County. Although not technically a manufacturing facility, we do have a number of processing equipment that you'll see on your virtual tour. We're truly a chemical company, one that makes specialty polymers, as well as composite materials. Here at our site in Alpharetta, we employ more than 400 people in a variety of jobs. Majority of those jobs are research and development jobs, which would probably be of most interest to you. So if you're interested in science or any kind of manufacturing, Solvay is an excellent opportunity for you. Anything from high school graduates can be technicians in our compounding in the pilot plant. If you wish to go on and get some kind of science degree, you can also be a research technician or one of the engineers on the compounding lines. Certainly those people that have PhDs in chemistry or physics or material science also have opportunities to create new polymers. So as we go on our virtual tour, we'll be able to see the whole life of a polymer, from when we first create it in the lab in just a small polymer reactor, to where we would go out into the pilot plant where we make larger batches in tanks, and then mix it with different chemicals and colorants so that it would be a final product that gets sent to our customer. We'll also show you some testing facilities as well as some additive manufacturing topics. So come and join me on this virtual tour.
Hey there, my name is Marianne Smith. I am a senior chemist here at Solvay Specialty Polymers. I work in our sulfone polymers group. So a little bit of my background. I have a Bachelor of Science in Chemistry from Georgia Tech, and I'm currently working on a Master's in Chemistry online as well. So I actually graduated from Georgia Tech, came to work for a while and decided I wanted to go back to school, and so I kind of have that opportunity to work and go back to school to kind of further my career along as well. Other colleagues of mine have slightly different backgrounds. I have colleagues who have, you know, a biology background or a chemical engineering background. So for this role, we have pretty diverse backgrounds where you know, anyone in the STEM field can kind of come and do this job. It's pretty exciting. Okay, and to give you guys a little bit of an idea of what I do day to day, I'm going to show you a basic polymerization setup, reaction setup, and I'm going to show you a little bit of the techniques that we use to conduct an experiment. So you'll see me add a solid by metering it in bit by bit. Some reactions that we run require slow additions, and you'll also see me do a dropwise addition of a solvent at the same time. Some of our reactions require that as well. It's very tedious, requires some attention to detail, and so I'll give you guys a view of what that looks like.
What you're seeing now is the pilot plant facility. Earlier, we saw polymerizations happening in a very small beaker. Here in the pilot plant, we're using much larger tanks to make larger batches before they are sent for commercialization at one of our industrial plants.
Hey, I'm Ralph Glover. I'm a technician out here on the floor. We screw plastic pellets. I got 15 years prior experience in plastic. That's how I ended up here. I love my job. You know, I graduated from high school, but I did not go to college. But I didn't need a college education to get here. But I had 15 years experience, so that's how I ended up here. Okay. Base resin. We fill up the feeders. These are called feeders with material. They come down the vibratory tray and they drop right into the extruder. They drop into the extruder, twin screws, bits it and melt it all the way until it come out the end, which is called a die. They come out the die to the water or onto a conveyor belt. The water helps cool it all the way. Come out on your slide. The material's still cooling. And it goes inside this pelletizer. This is the machine that cuts it up into small pellets. This is called a classifier. It's a cooling classifier. It cools it while it shapes it all the way here. It cuts it up into small pellets. And it disperses the big pellets into this bucket. And if they're too small, they kick it out into this bucket. And all the good pellets go down here and fall into the bucket.
Hello, my name is Laura Plank. I'm an associate scientist here at Solvay. I work in the industrialization group. This is our color wall. So part of what people do at Solvay is color plastics. And I used to work in that group, but now I moved on to work in some big plants, which is a lot of fun, helping industrialize some of these colors into big plants in China or Marietta, all sorts of areas. My background is I have a Bachelor of Science in Chemistry from Georgia Tech, and I started here as a research chemist. So I worked in the lab, lots of chemicals, it was a lot of fun, very exciting. And then I moved into a scientist role. My boss has a PhD in material science, and that's one of the options if you want to go into management, or he also worked as a scientist and then became overseeing other scientists with his degree. And yeah, it's a lot of fun. It's a lot of excitement here at Solvay. We do lots of new things all the time, and science is great.
My name is Bruce Clark. I work at Solvay Specialty Polymers. I'm a molding technician, specializing molding parts for testing and to qualify our materials for research and development and production. Right now, this is a molding machine. It's a 180-ton machine, so it clamps this mold with 180 tons. We shoot plastic into it at about 25,000 psi to make plastic parts. It takes about a minute to make the part. So right now I'm in the middle of making color chips. I have a 2-year college degree, but basically my background is just mechanical. I was real good as a kid, fixing things, building things, and it was just a natural fit for me to get into machinery. And when I went to school, I worked as a machinist and an electrician to get through school. A lot of our guys here that do this are just mechanics or electricians, just good at fixing things. And that's one of the biggest things that we need for people who work here is we don't need college degrees. We have plenty of scientists up front with college degrees to help us out. We need people that are qualified at running equipment and self-starters, don't need to be told what to do, and can just go ahead and do it. Right now the mold's going to close. It'll inject plastic into the mold, fill the mold up, and it'll make these color chips right here. When it makes it, these are about 750 degree molten plastic, and then they cool down in a mold to about 400 degrees when they come out of the machine. So when they come out, they're about 400 degrees. My hands kind of get used to that over a little bit of time. So I recommend for the kids who want to go to school but college is not their thing, the trade schools are an awesome opportunity. There's also a lot of other things like union schools that will teach you a trade. The trades are a great lifetime opportunity. It's a good career. You can make as much money or more money than a lot of people who go to college. So it's always something to consider, and if you can, come and join us, come see us.
Hi, I'm Justin Sarine. I work for Solvay, Solvay Specialty Polymers. So here we make all sorts of high temperature specialty plastics for various industries such as aerospace, automotive, oil and gas, really polymers that need to withstand chemical environments or anything that's high temperature requires exotic conditions. So the experience that's required here at Solvay to work here is really anywhere from a bachelor's degree to a doctorate degree, depending on your level of experience and the type of position you're looking for. So the type of work we do here is we design research, we think of new products that our customers might be interested in, or products that might fulfill a certain performance profile for a customer. And then we take those performance profiles and decide on, let's say, a formulation or a type of product that might be suitable for that customer. And then we do different experiments to sort of flesh that idea out or validate that those materials can actually perform to the specifications that are required by the customer. So here in the Additive Manufacturing Lab, we are designing materials for filament extrusion 3D printing, or fused filament fabrication, also known as FFF. And we also do some selective laser sintering work as well. So here we're taking different types of polymers that we make here at Solvay, formulating them for the customer's needs, converting them into a filament, which is the feedstock that's required for this filament 3D printing. And then we print different parts and then measure the properties of those parts so that we can then report properties to customers or inform the type of formulation work or say changing print settings that are required to achieve the properties that our customers want. We have a partnership with Stratasys, which is a leading 3D printing manufacturer, to create different formulations for their customers and that work on their platform. So right now we're printing some special test parts, flex bars, that look at the tool paths. So it looks at essentially how much infill or how the part is filled in, the 3D part is filled in once it's sent to the printer. So these are parts that might seem kind of boring on face value, but these parts provide data to us. We can take the flex bars and bend them in a certain orientation, or look at the infill to find the right print settings. So here in Additive Manufacturing, we 3D print a variety of different parts. Some of the parts are designed to mimic the application that we're trying to target. So for example, we have a 3D printed wrench here that's printed in this exact orientation without any assembly required, and it functions. So you can spin the gear and have it function. We've also got another wrench printed here on the filament printer, which is shown behind you right here. We've also got a chain that's printed on a selective laser sintering powder printer in this orientation. Again, no assembly required. And then we've also got some functional parts like a bolt right here. So you could print a bolt, say, out of a high temperature material that would need to withstand an exotic environment, and then use that in an actual application. We've also got some chain mail here, again printed in this exact orientation, with the powder from the selective laser sintering process acting as a support. So unfortunately, not all of the parts we print are as fun as this. Sometimes we have to print parts like flex bars, little rectangular bars like this, or tensile bars like this. So these parts may not look very fun, but they provide us the data that we need to make decisions on changes to formulation or changes to print settings. So the data we can get by measuring these bars, measuring the dimensions, or measuring the properties gives us information about how to go through the product development cycle, change formulation, look at what the customer needs, and then, satisfy the customer.
My name is Chris Bassett. It's the Polymer Characterization Laboratory in the Physical Mechanical Lab at Solvay Specialty Polymers. My background specifically is material science engineering, and what we're going to do here in just a moment is take a look at one of the kind of standardized routine tests that we run to support our scientists and engineering design teams. The frame that you see right here is a universal load frame. Basically what we're going to do is take a small piece of plastic, I'm going to hold on to one end of it with this lower set of grips, attach this upper set of grips, and pull it till it breaks. The small piece that I'm about to attach to it is just a way that I can very precisely measure the actual amount of movement, the amount of displacement. So, take a look real quick. So basically the purpose of doing this test is the kind of information that I can get from taking the specimen in this state to the specimen in this state can allow our engineers and scientists better ability to design, better ability to find solutions for maybe problems that we would have in a project or other problems that customers might have. And so even though it's a very simple tech test, you can get you can get a multitude of different types of information from it. So basically the kind of background that this lab is best suited for. Ideally, you would prefer a material science background, something with heavy load of solid state chemistry, as well as maybe kinetics, mechanics, solid mechanics, deformable bodies, and really physics in general. And so a physics degree would work. A chemical engineering degree would work. It's not so much solution chemistry that we do in here. It's more about we use what we understand about the fundamentals of solid state chemistry and mechanics to better characterize and test the kinds of materials that we see.
Thank you for taking this virtual tour with us. If you have any other questions about Solvay, please go see our website at solvay.com. And be safe and be well. Thank you.
Automation Directs is a place where they emphasize all the different aspects of your life. And so doing, it gives you stronger commitment to do the best that you can and work towards making Automation Direct even more successful.
The culture here is very powerful and very positive. I have responsibility for participating in a team that brings new products to the company, new versions of software for our existing products, and supporting the products.
The wonderful thing about a company is you can bring your ideas to the table, and they actually listen and support you in those ideas, and actually see those ideas to the market, which is a wonderful thing.
There are groups here to do a huge variety of activities. There's a running club, there's a gun club, there's a book club, there's a bike club, and the Ultimate Frisbee Club recently.
They care about what I do and the extra events, much like the Halloween stuff. I've never been to a company that did that kind of thing, and it's enjoyment. We just have the freedom to relax when we need to, and balance between your workload and your family life and your financial life.
I've been here for almost 20 years. It's been a great experience for me, and I wouldn't want to work anywhere else.
Hey, I'm Michael Callahan. I'm with a company called Swagelok, Georgia, Jacksonville, and South Carolina. We are located here in South Forsyth off of Shiloh Road, and we are a distributor and small manufacturer of some components for fluid system technologies. So the industries we typically work with are pulp and paper, power, pharmaceutical, and the way that I like to describe our products are in your house you've got copper tubing, regulators, valves that bring in your water, and that water comes in at a high pressure and it's reduced down. So we do that on an industrial level. So kind of going forward, think about a power plant. The way that they make power is by taking water, boiling it, taking that steam, pushing it through a turbine, which turns really fast and turns a generator, which ultimately makes power. So where our parts come into play is measuring that process. So they have to know what speed that turbine is going to generate at, that the temperature is not too hot, not too cold, and what pressure they're running it at, so they know what the output's going to be. So that's what we do here. As far as opportunities, we have internships. We have a custom solutions group that you'll see here in a little bit, and we put together our products that we buy and sell into panels, into smaller assemblies, so that the customer doesn't actually have to put those together when they get on the site. As far as education, right out of high school, you know, we have our technician roles, and then moving forward, college degree usually is what we look for when we're looking for customer service or technical support. And then we also have field engineers that are just an engineering degree straight out of college. So, and then as far as doctorate, if you have a doctorate, we'd love to meet you, but we're probably providing you products versus getting you what you need. So We've got marketing, we've got customer service, we've got engineering roles. We have a group of field engineers who actually go out to customers and they try to identify the problems and provide solutions. So we're fluid system experts, is what we like to call ourselves. And so when we go out, that's our goal, is to identify the problems and help customers solve them. So that's what we do here at Georgia, and hopefully you'll enjoy our video. All right, so this is our custom solutions area. So back here we make hoses of custom lengths. We also do some panels that you'll see in a little bit. And this is also where our warehouse is that has all of the components that we stock. So from a distributor standpoint, our responsibility is to localize our product offerings for our customers. And so our warehouse is full of local parts and products that our customers would need. So over here is our hose cell, and what we do over here is we basically cut to length the hose. We put the end connections in so customers can customize exactly what they need, whether it's one end connection and a different type or the same end connections. And then after we've put the hose together, we crimp it in this cell right here. And then once crimped, we take it over to be tested, and every hose is 100% hydrostatic testing. So we basically fill it up with water up to about 1,000 psi, and we test every single hose to make sure there's no leaks. And on those two pieces there with the yellow coming at the bottom, that's actually a new device that requires, it's kind of a quality inspection device to make sure that whoever's inspecting the hose actually has their fingers on it and is watching the hose the whole time. This is one of the new pieces that we just installed, and on the production order, so that's the order that we print out to tell us what parts go on it and how long to cut the hose, there's actually a barcode. So when Robbie scans the barcode, this tiger stop will actually come out to the distance that it needs to be, and then he'll pull the hose through, butt it up against there, and that's the measurement that he'll cut it. Out to make sure there's no cutting debris, and then he's going to put the end connections in with the collars on there that will eventually get crimped on.
Then the one end flares out, so you have to use a tool to get it in.
And so right now he's checking to make sure the overall length is what it was
85 3/4
set out to be.
No, excuse me, not 85 3/4, 30,
36.
35 3/4. I'm just measuring from the wrong. Okay, so now we're going to change the machine.
So what he's doing here is setting the crimp collar. So that's actually what's going to come down onto the hose collar to crimp and ultimately seal the hose. So what's going to happen is he'll put the hose through, and then this allows him to push it all the way in. Crimp down on that. And then he's going to check over here to make sure that that crimp is within the tolerance that.
4.4.
So it's another quality, quality check step. And up here is all the information for the hose. It tells them what size it has to be. So what was the
12.4?
So 12.4, and if you can see up here, the OD should be 12.4. And the range
12.5.
So the hose is hooked up, and what's going to eventually happen is he's going to turn on the pump. The pump's going to pump it up, and then he's going to put water into the hose, and he's going to let it sit there for 30 seconds and watch to make sure that there's no leaks. And once there's no leaks, he'll release the pressure and pull the hose out. Water. Now he's pressurizing the actual hose. and he's going to put his fingers on this device, and that's going to start the timer.
Hey, I can handle
3, 2, 1. All right, so now he's going to depressurize the hose. Open it up, and that releases the film, and then you can pull it out. All right, so this is our orbital welding station. With orbital welding, you can have a couple different types of welding. You have socket weld, which basically means you take the tubing and you insert it into the socket, and you're actually going to weld around the tube. So that's not the best weld because it only gets the side of the tube into whatever fitting. And then you've got butt welds. So with our orbital welding, what we're doing is we're taking the butt end of the tube, the butt end of the fitting, we're putting it together, and we're actually making a joined mechanical seal. So that's going to be the best weld. And this orbital welding machine actually does a lot of the thinking for us. But our team has to put all the information into it. And once it's done, they inspect every weld to make sure that it's to the quality requirements of the customer. And then a lot of times we'll clean it up and send it out. Yeah, so basically if you look over here, most of what comes into our custom solutions group is a bunch of product and a drawing. So they take all of the products and the drawings, and then they transition it into something like this, which we would call a completed product. So this is a set of panels that's actually going to regulate a larger valve in the oil and gas field. And so our team basically they bend the tubing, they thread all the fittings in, and then they hook it all up to where the customer would be taking this panel and putting it into whatever the final production is. And so the benefit to the customer is they don't actually have to do all of the assembly. They don't have to do any of the testing. It's already done for them. So this is our warehouse where we keep the majority of all of our products. We've got a warehouse here in Alpharetta, here in Forsyth County. We've got one here down over in Greenville, South Carolina, and one in Jacksonville, Florida. And basically what we have is a bunch of smaller components that go into manufacturing facilities, industrial facilities, and they take these and either repair or add on to whatever process they have. So we have sizes all the way from 1/16 of an inch, which is extremely small, all the way up to 2 inch here. And this is actually, when you want to talk about 1 inch fittings, nothing's going to be opened. Let's see. So this is going to be a 1 inch fitting. And then these are, once you get up into 2 inch, the size obviously gets much larger and more expensive.
Hello, my name is Ron Young with Collins Company. We are a manufacturing company based in California with also a location here in Cumming, Georgia. We manufacture windscreens, sports netting, and wall pads for universities, parks and recs, high schools, and neighborhoods. As you see, this is Mississippi State, one of the large universities that we did for the baseball program, where we did the netting, backstop wall pads, and also dugout rail pads and outfield wall pads. In Forsyth County, we've actually done work with all the schools in this area, with all the fields, indoor gymnasiums, etc. In our location here, we also have about 21 employees in the fabrication and manufacturing side. They all have a high school diploma or higher. And our sales team only have a 2-year degree or higher as well. And in management, you're probably going to need at least a 4-year degree or higher. And from that, we'll shift over to some of the work that we do at this facility. So as part of our sales process, our sales team will go out and they'll get measurements at certain facilities. Now they'll bring those measurements in-house. Then we'll take the material that was sold and we will cut it to size to be specific to the needs of that job sold. In this situation here, we do a lot with the construction market, and this is called privacy screen. So we cut this down to size for specific fence sizes, etc. Another one of the processes we do here is, as part of our sports netting, is divider curtains. And this situation here, we are actually sewing on some vinyl onto some netting that will go into an indoor batting cage area. The sewing process with some products takes up to 2 people to pull the product through to ensure you have a straight and even sew line. So once the fabrication process is done, we bring it over to this machine, which is called a grommet machine, where we add the grommet into the outside border. That allows you to hang the material on the fencing or in the proper areas needed at the sports facility. We also manufacture the wall pads for facilities as well. For baseball backstops, we do outfield wall pads, we do indoor gymnasiums for like basketball gyms, etc. And those are also typically made to size to fit the need of the actual customer. These are manufactured with wood background, with foam, and then wrapped in vinyl. And we also do digital logos as well, which I'll show you a picture of that shortly. So this is a sample of our digital logos that we do for our wall pads. Logos can typically be the size the customer needs, typical size of 4x6, or it could be larger. Again, the wall pads are based upon the needs of the customer and the facility in which they're going to, whether it's an outfield wall pad, which will run bigger than standard wall pads for indoor facilities like basketball gymnasiums.
All right, my name's Tim Ferguson, and I'm here with you from Siemens Mobility, the Alpharetta plant in Forsyth County, over here in Alpharetta, Georgia. We make many components for rail cars. We make the inverters, which are basically the motors, or the engines, if you will. We make the motors for the drivetrain, and we make the gearboxes or the transmissions for the motors, for the locomotives. And that's most of what we make here, but we also make some sub-assemblies, some panels, some wire harnesses, various other products that we use within our products. And we do make some sub-assemblies for other Siemens locations and wire harnesses for other locations at our site. Most notable, we're working to try to get a contract for MARTA here locally, so hopefully we win that bid. We'll be doing that work here in our own backyard for the city.
Hi, my name is Kim Howe. I'm the logistics manager here at Georgia 400 and Alpharetta at Siemens Mobility.
So this is our wire center. This is particularly the termination area. And what happens, the harnesses come over here after they leave the harness boards. And we put the terminals, the lugs, the ferrules on the harnesses here. These harnesses will go either to our products internally in the factory, or we actually ship some to other Siemens locations for their use in their products in that area. There is a fair amount of growth for us in this area for our business, so we are looking to increase the number of employees in this area. We'll increase the numbers in termination as well as increasing numbers in the harness boards. We are looking at a project that will add a couple of new machines to this location that will print. It will spool off the wire, it will cut it to length, it will strip the ends, it will print the identification on the wire itself instead of using slip-on labels. And these machines will require some operators as well. Yeah, so this is our test area, and the harnesses come here when they're through assembly. You can see on the test board back there, there's many different kinds of connectors, and each harness has a subset that they connect to, so the tester has to figure out which connectors go to what connector on the harness. It sometimes takes a half hour up to 2, maybe a little more, to do all the hookups on a harness depending on the size. And then we have a computer here where they actually run the test, and that software will check for opens, shorts, and it does a high pot check on the cables so that it knows that it's good to go. And from here, they'll take it over to assembly or take it to shipping.
This is our label and engraving center. All of the products that we build here have to be labeled properly with the part number identifier and a serial number, and we custom make every label and engraving. The machine requires an operator, but can operate once it's on by itself, allowing the operator to do other tasks at the same time. The skill sets needed for this are just attention to detail, awareness of the safety concerns around the area, and ability to operate these machineries.
All right, this is a new line for gearbox assemblies, basically a transmission for a locomotive or these in particular are for like a MARTA train. The skill sets required over here are just mechanical assembly, attention to detail, We do operate cranes over here, so the person has to be safety-minded working in this area. But this is also an area we're adding more positions to as we have continued growth coming in the year coming. This area is part of our paint booth. This is where they actually do the paint line. What we have here is some of our motors for a Metro unit hanging in here. The painter will apply the thicknesses of paint. He uses tools to measure the thicknesses prior to application of paint. This is primer coat you see on here, and then he will apply the finish coat and then take another set of measurements to make sure that we meet the specifications. And again, in here, this area has a little different requirements for PPE or personal protection equipment, and some respirators are involved here. So a person that works in this area has to take a test with a medical examiner, make sure they can wear the respirators properly throughout the day. But this is an area with the skill sets. There's attention to detail again. Doesn't take anything other than paying attention so you don't get runs or drips when you're painting the surfaces.
This is our motor assembly line, and this is another very new product to our factory in Alpharetta. We took an existing line and had to tear down the equipment because it just wasn't suitable for the motor line. So here you see new cranes in operation, a couple new jib cranes. We have ovens, we have freezers, and there are many process steps to assemble these motors. The parts come to us with a film on them that requires to be washed. So the parts get washed and dried and put together on the line for the assemblers to continue the process. Many different components and tools are used, different types of chemicals, so awareness of those is necessary, but a lot of good opportunity here. And these motors are used and for a train similar to MARTA, and they operate train cars like those. Another component that comes out of our factory are inverters. And these are components that go either underneath or above a train car. And they help accelerate the train, and nice ramp up, nice ramp down to control the speed properly. They're just filled with electrical and mechanical components, and they're really the brains of the train. We build these inverters for train cars for all over the United States and Canada. And this is truly one of our best competencies here. It requires knowledge of mechanical components, electrical reading, schematic reading, and a reading of bill of materials.
Okay, so this is our CMM, or coordinate measurement machine. And what it does is it measures a device with a very pinpoint fixture on the head of it. So we have here, this is a bearing ring that's up for measurement, and they will use either the desktop or the joysticks that are there to control, or it has an automated program that will run. And the operator here is checking the measurements from the specifications on the engineering drawing to make sure that the part is accurate and built as required.
This is a carousel system that we use in the warehouse at Georgia 400 to store a lot of our small components. It's a four carousel system, and the density is very high considering the limited space that it actually does take up. It runs off an automatic entry system, so I just plug in the carousel bin that I want it to go to, and it will automatically move to that location. The platform raises up to get to the second level, and this is where the warehouse operators come and to pick the parts and to stock these small components. The warehouse is an operation that manages all material. We are responsible for receiving in all goods, stocking them securely and safely, picking them for our production floor, and shipping out the final goods. We also have a quality inspection area and more quality behind me, as you can see in this room. An operation takes so many different types of roles and people to fill those roles, along with various skill sets. We talked a lot about what's in the factory, what's in the warehouse, but there are also a lot of support roles that are required to continue building and maintaining a factory. These roles include supply chain management, purchasing, planning of the parts and materials and the operation. We also have a team of manufacturing engineers who support production and look at ways to make our processes even better. All of these roles can start at an entry-level type position and grow. We're looking for people with high school diplomas, 2-year, 4-year, and even graduate degrees to fulfill these roles in various capacities. We're always looking to bring in interns and high school students to start learning and developing them even further, even beyond what they learn in the classroom, and get real-world experience at Siemens.
I would like to thank all of our manufacturers for participating in virtual National Manufacturing Day. It was a lot of hard work to put this together, and I hope you enjoyed our virtual tours. As you could hear throughout the presentation, a lot of these manufacturers are currently hiring at a lot of different educational levels. Whether you are looking for a job straight out of high school, you're looking to go to one of our local community colleges and get a 2-year degree, or if you're going to go and get a 4-year degree, we have lots of opportunities for you to continue to work, live, and play in Forsyth County.